So, what if you could build a private AI employee, one that costs you exactly $0 to run? Today, we're going to do just that. We're going to assemble it piece by piece right on your own hardware. This is the Trinity Stack. Let's get into it. You need to stop renting your intelligence. Seriously, right now, your company's AI strategy, it's probably just a fancy API wrapper. You're paying a cloud tax to read your documents, another tax to think about them, and a third tax to speak the answers out loud. It's a trap. I mean, just look at this. On the left, that's the trap most people are stuck in. The API wrapper. It is expensive, it is slow, and the worst part, you are actively leaking your proprietary data to 3 different mega corporations. But on the right, that's the solution, the Trinity Stack. It costs nothing but electricity, your data never ever leaves your firewall, and you own the entire process, end to end, total sovereignty. So, enough talk, let's actually build it. Today, we are putting together the Trinity Stack. This is a fully private AI employee with 3 core abilities. It can see, it can think, and it can speak. And you know the best part? You do not need some massive, unobtainable H100 cluster. This entire thing can run on a Mac Studio or even a decent dual GPU workstation you build yourself. Okay, first things first. Every employee, digital or human, needs to be able to read. So for the first piece of our stack, the I, we're going to use something called DeepSeek OCR-2. But you might be thinking, why not just use any old OCR tool? Well, for years, we've been stuck with what I can only call dumb OCR. Tools like Tesseract, they just read pixels, strictly from left to right, top to bottom. The moment you give them something even a little bit complex, they just fall apart. And this slide right here perfectly shows the problem. You feed a dumb OCR, a multi-column PDF, or a dense table, and it just vomits out a jumble of garbage text. It has zero concept of structure. DeepSeek OCR-2, on the other hand, understands the logical layout first. It knows column A is a separate thing from column B before it even starts reading the words. So how does it do it? The secret sauce is this technology called Visual Causal Flow. Instead of a rigid, dumb scan, a vision transformer takes a global look at the whole page and predicts the logical, human-like reading order. It reads a headline, then the main body, then it follows the columns correctly. It's the huge difference between just seeing pixels and actually comprehending a document. And check out the specs on this thing. The cost, $0. It's open source, Apache 2.0 license. It's a pretty lightweight, 3 billion parameter model that only needs about 16 gigs of VRAM to run. You can deploy this thing locally with total privacy and complete control. Just like that, our AI employee can now read. Okay, with the eyes in place, it's time to build the brain. This is the reasoning engine, and for that, we're going to use a specialized model from AI21 Labs called SERA. Now look, I could tell you to go grab some massive trillion-parameter model, but unless you've got a spare $40,000 for a server, you can't actually host it. Those giant models, they're generalist philosophers. For real work, you don't need a philosopher, you need a surgical worker. You need a smaller, specialized agent that just gets the job done efficiently. So meet SERA. It stands for Soft, Verified, Efficient Repository Agents. Now, this is a 32 billion parameter model, but it punches way, way above its weight class. Why? Because it's a specialist. It wasn't trained on poetry or random facts from history. It was trained specifically to navigate complex code repositories and file systems. It knows how to find things, how to execute tools, and how to get tasks done. The key innovation here is a brilliant technique called soft verified generation. It solves a huge training bottleneck. See, instead of needing these complex test environments to check if a code change is correct, it just has a teacher model make a change, and then it has the student model try to reproduce that same change. If the code lines match up, it's verified. It's a simple, amazing hack. Let's just walk through this process on the screen because it's pretty clever. In Rollout 1, you have a teacher model make a code change. That change gets turned into a synthetic pull request. Then, in Rollout 2, the model has to try and recreate that exact patch just from the description. The soft verify step is dead simple. It just compares the 2 patches. If they're close enough, boom, you've got a high-quality training example without ever running a single slow unit test. So what does all this cleverness get you? How about this? This method is 26 times cheaper than traditional reinforcement learning approaches. This is how you kill the cloud tax. By innovating on the training method, you make state-of-the-art specialization accessible to everyone, not just the people with giant budgets. So, here's the tail of the tape for our brain. Again, cost is zero thanks to the Apache 2.0 license. It's 32 billion parameters, and it needs about 60 to 65 gigs of VRAM. That fits perfectly on a high-end Mac Studio or a workstation with a couple of 3090s. Our employee can now see and think.
All right, our employee can see and it can think. What's missing? It needs a voice. If this agent is going to work in sales or support, it has to be able to speak. For this, we're going to use Qwen3-TTS.
Now, the industry standard for this is 11 labs. And yeah, it sounds great, but it has a latency of around 500 milliseconds. In a real conversation, that half-second pause, it's an eternity. It feels awkward, it feels unnatural, it's a conversation killer. Compare that to a self-hosted Qwen3-TTS, which can respond in under 100 milliseconds. 97 milliseconds. I'm going to say that again. 97. That is faster than you can think. It is so fast that it allows for real-time interruptions, which makes conversations feel fluid and natural, not robotic and delayed. The magic behind this incredible speed is its dual-track architecture. And here's the key idea. It doesn't wait for the entire text response to be generated by the brain. The moment the first few words are available, it starts creating and streaming the first audio packets. This completely wipes out the generation delay, and it's what allows for truly real-time conversation. Okay, so we have the parts. We have the eye, the brain, and the mouth. How do we stitch this Frankenstein's monster together into a single, cohesive employee? Well, we create a simple but really powerful architecture I like to call the private link. The data flow is really simple. Step 1, the input layer, a PDF or an image comes in, hits the DeepSeek OCR container, and gets turned into clean, structured Markdown. Step 2, the reasoning layer. That Markdown gets passed to SERA, which then decides on an action. And finally, step 3, the output layer. SERA's response is fed right into the Qwen3-TTS container, which streams the audio directly back to the user. And the benefits of doing it this way? They are profound. You have no API keys to manage or leak. You have zero data leaks because every single thing happens inside your own firewall. There are no surprise per token bills that are going to bankrupt you. You're not just building another chatbot. You are building a sovereign digital workforce. Let's wrap this up because I want to talk about mindset. The choice between renting some API and actually owning your architecture, it's not just a technical decision. It's a reflection of engineering seniority. Junior engineers look for the best API to call. Senior engineers, they look for the best architecture to own. The tools to own your stack from top to bottom are finally here. They're open source, and they are powerful enough to run on hardware you can actually afford. Stop renting, start building.